Thank you, Gary. Good afternoon to the distinguished chair, Stuart Hamilton, and Secretary Gary Webb, IWA Water Loss Specialist Group, participants from academia, industries, and so on. So, we are going to deliver a webinar on water informatics for water loss. Our speakers of the day are Professor Amlan Chakrabarti and Dr. Jyoti Gautam. Before we start, I would like to give a brief introduction of the speakers. Professor Amlan Chakrabarti. He is a full professor in A.K. Chaudhary School of Information Technology at the University of Calcutta. He is an MTech from University of Calcutta and did his doctoral research at Indian Statistical Institute, Kolkata. He was a postdoctoral fellow at the School of Engineering, Princeton University, USA during 2011-12. The second speaker is Dr. Jyoti Gautam. She is an associate professor in the Department of Computer Science and Engineering at JSS Academy of Technical Education, Noida. It is affiliated to Dr. APJ Abdul Kalam, Technical University, Lucknow, Uttar Pradesh, India. The webinar layout is as follows. We can start with the introduction to water informatics, then data links provided here, water distribution management. The next topic is analytics for water informatics, IoT intelligence for water informatics, challenges, then case study 1 that is on monitoring and forecasting water consumption and detecting leakage using an IoT system. The second case study is about Chennai water problem, calculating zone-wise deficiency. Then conclusion, the future scope, and the last one is the references. This will be followed by a video on water loss and impact of COVID-19 on water loss. And finally, a feedback form, which link is given, provided in the chat box itself. So, may I request Professor Amlan Chakrabarti to start delivering the webinar. Please, sir.
Okay, great.
Yeah, so thanks, Gary, and thanks the organizers of today's seminar, the Water Loss Specialist Group. So what we will speak today is basically on the role of water informatics in the water loss. This presentation is divided into two sections. The first section, I will be speaking upon the water analytics and the brief way we can use water analytics for water management. And the next part will be taken over by Dr. Jyoti, and she will be picking upon some of the latest work, what we have done based on the sensors and analytics for building a prototype. And also she will focus on the work, what we have recently done on estimating the water usage. So without wasting much time, I will be just starting my presentation. So as I told that this presentation looks towards the understanding the need of water management for water loss prevention and for better water management, and obviously the use of technology, the technology like IoT, technology like analytics and machine learning, so that we can have a data-driven ecosystem for the management of water, and that will help us to prevent the water loss. And so we will discuss about the analytics, the management, and the IoT enabled technologies to facilitate this scenario, which will be, then we will follow up with some of the works what has been done in this domain for prototyping and experimental results for those work. So what is water informatics or hydroinformatics? So we know that when we try to apply the information available in the domain and try to control our processes, that is what is called as informatics. So that's if we try to do in the domain of water management, to understand the water usage, to understand the water quality, to understand the water distribution. So what it means that we have to capture the data to the sensors, we have to propagate the data to the networks, we have to try to find the insights of the data through analytics, and that will obviously help us to generate a lot of utilities, and to also to monitor the process, and to serve the society with a better and with uh, sufficient quantity of water supply. So if you look into the data scenario, what we can have in this domain, there are different ways we can collect the data. There are history data available with the world organizations like UNESCO and many of the world, how this water has influenced the society in terms of agriculture, in terms of industrial usage, in terms of consumption of drinking water, right? So the water data, what we can have, or what we can try to work out in the society at a large, is something called a groundwater site information, which is called as GWSI, which actually tries to take the data for the groundwaters. And obviously there's a water quality data which tries to measure or tries to estimate the quality of the water in terms of different types of components which are available in the water, like inorganic and organic components, like trace metals, which may be harmful for our biological world, and also the sediments and the other type of affluents which can mix in the water. The third is a sort of automated data processing system, right? And this is a data processing system which actually focuses more on management and the control of the water in the real time, right? And that's why it does a lot of processes for estimating the flow, for analyzing the time-based data for the various supply conditions, and so on. Last but not the least, there is something called water usage, and which is very much of use because of the present scenario of water shortage, right? We have to estimate the water data, the usage of water data in the different geographical regions, in the different cities of a country, maybe among the different types of communities in a city, right? And obviously, Dr. Jyoti will focus on data and develop analytics which can efficiently do this job. And obviously, as I told, there are a lot of repositories. There are a lot of data repositories in the public domain, like India Water Portal data. We have multiple data sources from the Kaggle, which is the very well used data set for public domain. And obviously there are multiple data sets which are available from the different world organizations. Now obviously we have already discussed that what is the water management and what are the data sources, but how it actually influences our life, that's the biggest thing we want to get into. And we see that every span of life, the water data can play an important role, right? Water data can, so obviously water data is the most important purpose of the way we use the water for our household activities. The most important is the drinking water and also water for other activities. And so we have a limited natural resource of water, which are getting depleted with the different climatic changes, with the different flood conditions. The water gets contaminated and might not be very well used for our household activities, right? And so extreme weather, climatic changes, that means what are the influence of this on our water body and water reservoirs is a good thing to know, and obviously to use that for saving our water resources in the best possible way. Water is used by industry, water is used by agriculture, and obviously the water distribution, the way the water is distributed is some sort of, it is not a constant way, or it doesn't have a very constant property of distribution. By what it means that the water in the different regions of a country or different regions of a city, right, are distributed in a different way, in a different point of time. So there is a variability in the water distribution as well as in the water consumption by if you see the different sectors of the society. So now this is a scenario which is being demonstrated or illustrated by the particular figure, which actually focuses that how the water from the raw source is being used up by different sets of customers. The most common customers may be the household activities, a common man. But the customers can be industries also. The customers can be agricultural people also, okay, who practice agriculture and farming. So obviously the water from the raw sources are being prepared, are being filtered, are being treated so that they can serve the particular purpose of the water use. And then obviously after the water is used, obviously the water waste is developed. The waste is developed, which is called the sewage, right? And that is there is a process by which the sewage goes in the outlet, and obviously for the better conservation of water and for the ecosystem also, we have to treat this sewage so that the contaminations or the very harmful components are get disassociated and are collected separately, so they can be destroyed in a different form, whereas the good components can be preserved and can be utilized for some other purpose. And if we can regenerate the pure water which is separated from all these contaminants, we can actually flow the water back to the regular supply. So this is the process which are followed in many of the metropolitans across the world, and for the various uses. And right, and so what we try to, obviously we see there are different facets we can focus when we are trying to focus on water management. It may be that how the water is collected from the raw source, how the water is purified, how the water the switch control of the water is done. But the most important part where we need to focus, or what we need to focus in terms of water loss, is actually the water distribution management, right? And if the distribution management is perfect, both in terms of the supply quantity and also preventing the loss in the source or at the end where it is used, I think we can save a good amount of water, and that will be very useful for our society. So in order to do this, what we have to do, we have to generate, or we have to analyze what is the demand supply. So as the source of water is limited, we shouldn't use that water. There should be a sort of budget, or we should not overuse the water. That should be our target. So what we need to do, we can take the use of the sensors. We can try to generate models of the water usage for the various sectors of the society, be it household sector, be it agriculture, be it industries, and be it for other applications. And we can accordingly we can distribute the water in a very well fashioned way to all these sectors of the society, right? And for this, obviously, what we're trying to propose is the use of technology and the use of the data and analytics to help us to satisfy these requirements. So now I come to the important aspect, which is called the water analytics, under the purview of water informatics. So as we know that analytics means that from the data we try to churn out the insights, right? And these insights will actually give us the story, which will tell us that what are the consumption rate of water in the different population classes. What are the consumptions of water in the different zones of activities? What are the amount of water which gets as a waste out of all these processes, and what is the what should be the optimum way we should control and manage this particular scenario. So this, if we can do this, obviously we are trying to solve a lot of, we are trying to save water first of all, and what we are trying to do, we are trying to also give a sufficient, or give a very apt supply of water to the individuals, so the different processes can run in the society. So if you look into the analytics domain, this is a very structured platform how the analytics are being used. So we can have the physical assets, which in this case we can take the water resources, the natural water resources, or maybe the water which is stored in reservoirs, or the water resources which are generated from the rainwaters, right? And then we will use the sensors and telemetry. So the sensors will try to estimate the different properties. It may be the water volume which is getting increased or decreased in each hour or in each day of the month, right? Or it may be the water quality, the contaminants in the water, whether they are getting increased, or whether it is crossing the threshold, whether the water is still fit for usage in the various forms, right? And this type of and also the water volume, the water loss, all these things are different, and the different supply chain of the water resources can be collected through the sensors, and telemetry will be used to transfer this data which is collected to the sensors, to the different control and operations or management centers, okay, who can take the needed decision to how to do or how to perform in a proper way, so that the things are much within the control, right? And obviously the SCADA and the real-time systems which are for monitoring or the data acquisition, real-time data acquisition, those will be in place, so that it can be done in a very automated way, right? And then all these sensors and all this communication infrastructure will generate a lot of data, and surely it leads to the big data. Because why it's a big data? Because water usage means a large population, right? And a diversified population. If you try to take a water usage in a city in a different points of time, in a different hours of the day, right? What we find it is a good amount of data, right? Because population is large, the usage amount is also large, right? And also there is a variability, right? And if we try to increase this over a state or over a country, obviously the data becomes a huge data within a small amount of time. So it really leads to the big data problem, and as it is a big data problem, we can look into the different types of ways or opportunities to do the data discovery, and we can use the statistical models to generate the predictive or prescriptive type of analytics which can be generated out of the data, and then smart apps can be developed, which can show the different types of performance of this data, and as well as can give as triggers on action items for the different individuals, okay, the users, the water management people, the water service people, different types of triggers on action items based on this data. And this can be a very holistic way of managing the water resource in the best possible form. So the technology, what comes into play is that obviously the IoT devices means these are Internet of Things, and the Internet of Things are very small, very tiny devices, which has the way to capture the data through its sensors, and can also communicate the data through its communication interface, right? And through the communication, it can go to the cloud, and cloud is a large repository where we can store a large amount of data, and from the cloud, a lot of services can be accessed, right? So as I told, it can be a services for water supply, it can be a services for water quality, right? It can services for water usage, right? It can be a services to know the water increase or daily decrease. It can be a services to know the waste or the contamination of the water which is generated each day. so a lot of services can be generated by integrating the platforms of IoT, the cloud, and the smart applications at the services end, which can cater the need of various users, and that will lead to a very efficient use of technology for an important uh, uh, for an important part of our society, like water usage and water management. So you saw that there are different commercial IoT uh, stuff are available in the market, and we can pretty well use this IoT to take the data and to control lot many operations in terms of water management, water usage, water quality. And obviously in our project, when Dr. Jyoti will brief, she will discuss about some of the sensors what can be well used, right? And you see that it is really a snapshot I'm presenting, but there are a lot many more, and we can have it based on the particular problem we're trying to solve in the domain of water informatics. So the analytics for water conservation, obviously water usage. That means if we try to do our water management, and we try to make our water usage very efficient. Obviously, what we are leading to the water conservation, right? And that water conservation has a lot of aspects, like lot of things it can generate, right, based on the data analytics, right? And okay, and it can respond to emergencies, okay, respond and avoid emergencies, which means that there may be a sort of flood, or a sort of maybe there's a water emergency in terms of some acute water shortage in some part of the state or part of the country, right? And those things can be very well analyzed, and can be predicted, and so if it can be predicted, we can take accurate measures before the things can happen, or if the things have happened, also we can respond in a very immediate way, right? And obviously there are a lot of ways we can actually so use this, and there is obviously a revenue model which needs to be generated, because nothing comes free. So whenever we try to offer the things in a very well fashioned way, there is a cost associated with it. So we can model the cost and the reflections of the revenue based on the analytics what we can exploit, right? And obviously this can solve the maintenance problem, or this can address the maintenance problem in terms of water leakage, in terms of defects in the pipes, in forms of water contamination, and so both in terms of the quality of the water, for the maintenance of the water, for the responding to the water supplies in the emergency cases, can be well done if we are following the path of analytics. So now when we speak about analytics, what we come into the domain called machine learning, right? And machine learning is nothing but to use the data which are being collected from the domain, and to train our systems, and to generate very efficient models which can help us to predict or to prescribe an outcome, okay, before it has actually happened, right, based on our past data, right? And that is the fantastic domain of machine learning. I'm not getting into very great details of it, because it's a very vast subject, but what I mean to say here is that the machine learning models can be developed based on the water data, and can generate very robust models which can work for the prediction of the water volume or the water quantity, maybe for the next 2 years of a particular country or a particular state of a country, and the government can plan accordingly. We can do it for our households. We can do it for a factory, right? Like, and what are the waste, and what are the losses we can have in terms of the water usage. We can also predict that, and we can plug the loopholes in that particular way, right? And that's why to using the data and to generate the predictive and prescriptive models for water management and water usage using the machine learning models can be a very good roadmap to establish this in the best possible way. And so to summarize, what I need to tell is that obviously the ML or machine learning for water informatics can help to generate our improved model for water usage, for water leakage, for water quality, right? And obviously it can try to find out the errors in the system very efficiently, because when we run machine learning, we can find that, okay, this was what should have happened, but this hasn't happened, which means that there is a sort of error in the system, and we can find the outliers in the system using this type of models, and these models can efficiently detect the errors and the faults in our system, right? And obviously the anomalies, what I was talking about, the anomalies can lead to a lot of introspection of what has happened and what new has happened in the environment, right? To act to support that, or to take a protection from that particular behavior or change in the environment, right? And obviously based on the data, we can use it for taking the policy decisions, for taking the different types of pricing, for taking that, hey, whether we need to expand your water network management, or the water management is sufficient, considering the current population of the state or the country, right? And obviously it will help us to better distribution and controlling of this water flow. So I will just try to highlight that means I have explained all the things in a very, that means I feel I've explained all the things in a very positive way, and I have tried to focus that what are the best things we can do, but also we need to keep in mind that there are certain challenges. It is not a very easy task always, right? Why? Because the data of this type of data, which is basically the water usage data, or the water source data, or the way the water moves in a particular network, right? It is not a static data, right? It is driven by event, driven by time of the day. It is driven by the number of people who are using the resource at this point of time, which involves a lot of variable parameters, right? And so it is a non-stationary type of data. It is a sort of oscillations. It will just try to look like a noise data, okay, in general, which has a lot of variations, right? So to analyze the data and to take an insight out of this type of variations is a little bit difficult. So we have to go for specific type of time series type of models or statistical models to analyze and to find the true insights out of the data, right? And the second thing is that means, as it is for our common man, for our societal need, it's not for a special scientific function purpose. It is for a very general purpose, right? So if you're trying to do for a very general purpose, you have to have the model enough flexible, enough general. Okay, it works for one location of my city. That means it has to also work for the other region of my city. It has to work for the other regions of my country and the world. Obviously, there will be the different variabilities, but my model will be sufficient to accommodate those parameters and to reorient in a flexible way, depending on the parameters which has been generated or which has been supplied for a particular water data in a particular region or in a particular state. So that's all I wanted to speak about, just to create an environment that how we can use the water data in the best possible way, and what are the means to use the data in the domain of analytics and machine learning, and also what are the challenges when some of us take this as a particular workflow there are certain challenges which we have to understand and which we have to take care when we try to do that. Now I am giving it over to Dr. Jyoti, where she will speak about for the specific research projects what we are doing in a collaboration. Over to you, Professor Jyoti.
So can you stop sharing the screen so I will start?
Yeah, I have just stopped. You can just start, yeah.
Thank you, sir, for sharing your knowledge and thoughts. Now I request Dr. Jyoti Gautam to continue the webinar. Ma'am, please, sir.
Good afternoon, everyone. Now I would like to start my session. So I will start sharing the screen. So I will just start with the two case studies that I had to discuss. So actually my case study focuses on the challenges of urban water systems, which is faced by fast growing cities. My project has been developed in the JSS Academy of Technical Education, Noida, in the state of Uttar Pradesh. The setup has been done basically for the 16 households, which were connected to the 2 water tanks. The project helps to monitor the water usage and gives control to the user to make optimum utilization of this resource. It helps to regulate the water supply by stopping overutilization of water and leakage losses, thereby reducing water wastage. The development has been made through the IOT platform and the cloud edge infrastructure. So why this project is required actually, as it's quite clear that most of the cities in India are approaching to day zero condition, and it was published in the Nature Asia magazine. Well, now what's a day zero basically? The day zero is a day when a city is trapped, dry out, and people have to stand in line to collect a daily quota of water. Now, it has a certain impact on water savings, as it was proposed by the government of India that 55 liters of water per day should be given to a user in the water guarantee plan, which was published on 29th of August 2019 Hindustan Times. Presently, we don't have any control over water, and there is no metering with the water user in India. So basically, this project helps to achieve water conservation. This project is targeted towards realizing the dream for water conservation as proposed by the government of India and the whole world. So the project is actually, it helps to collect. The title of the project is Monitoring and Forecasting Water Consumption and Detecting Leakage Using an IoT System. So the objectives are collecting water level consumption data from water tanks installed on rooftops at JSS 80 Noida staff quarters, performing the pre-processing steps on the data, analyzing the data, and applying SVM, the support vector machine algorithms for forecasting water consumption, leakage detection, and leakage rate. A web interface has been designed for the users for visualization purposes. The location of the work, as it has already been explained, that it has been developed in JSS Academy of Technical Education, Noida, in the state of Uttar Pradesh, India. This project is a collaboration between Professor Amlan Chakrabarti from University of Calcutta, India, and Dr. Jyoti Gautam, myself, JSS 80 Noida. It has been published in the water supply paper. So the present status, we have been able to develop an IoT-based smart system for monitoring water usage in an urban environment. We have proposed a machine learning based technique for forecasting user consumption requirements. A water leakage detection based algorithm has been proposed based on the user input. Then a visualization interface has been developed for the users to estimate, predict, and detect leakage. There are certain technical aspects of this paper as a smart IoT node. It consists of an ultrasonic sensor, an Arduino node, a Wi-Fi module, and for the purpose of forecasting, we have used support vector machine algorithm. So this is the leakage detection algorithm. So initially, as it has been explained, the data is taken with the help of an ultrasonic sensor, which is installed at the rooftop, which is installed at the top of the water tanks, which are installed at the rooftops in a particular society. Ultrasonic sensors have been used, and the data is measured, taken from them. So initial water level is recorded, and we have to ensure that there is no water supply and consumption. And if the case is true, then the leakage detection is obviously not possible. And if it is no, then we have to wait for a certain amount of time, and we have to record another water level. And if the two water levels are equal, if it is yes, it means no leakage, obviously. And if it's no, it means the leakage has been detected. So these are some of the visualization interfaces, the web user interfaces, which have been developed for the users. So we can look over here, like we have one of the attributes is ID, then another attribute as water level initial in centimeters, date and time initial, water level final in initial, date and time final in use, number of users, and leakage detected. So the total number of users in this particular case have been 24 for 16 houses. So like if you look over here, the leakage has been detected for the ID number 6. So if you look over here, so we don't have the water in use over here as per the requirement of the algorithm. So the initial water level has been recorded, which is 33 centimeters, and this particular level has been taken from the top of the water tank till the water surface. And if you see over here, there is a difference in the water level recorded, which is 34 centimeters. It means there has been a drop in the water level. And if there has been a drop without the various users using the water, it means obviously a leakage is there, and the leakage has been detected. So this is one of the interfaces, and the another interface is basically, if you look over here, the same kind of an interface, but with a little difference. We have added the rate of leakage over here. So again, the number of users is the same as has already been explained. So if it is in use, so obviously the leakage cannot be detected. But if the users are not using the water supply, in that particular case only, the leakage can be detected. And if you look over here, with respect to the ID number 10, there has been a drop from 34 centimeters to 35 centimeters. So there has been a difference in the water level, and the rate of leakage can be detected. So now there are certain social aspects of this particular paper. Basically, it's helpful to predict the future water requirements based on the collected data, would rather help in distributing equal quantities of water to all the people. So the particular system can be expanded for a society at large. The same system can be installed as a network of IOT nodes for a housing society, which is having multiple water tanks. The data which is collected would be helpful in understanding the water usage patterns of the people in that society. The system can be enhanced with fog nodes for an urban area. The data can be sent to the cloud for running the analytics engine. So the basically proposed IoT-based system and the analytics engine could help further in understanding the daily, weekly, monthly, seasonal requirements of water for a district or a city, and finally the country as a whole. Target group would be the consumers, the smart cities stakeholders, colleges, large campuses. The cost of implementation to household in a society for 1 year. So like, let's say here the cost has been given for 10 nodes. So like the ultrasonic sensor cost is rupees 2,000 per piece. Then we have given the Arduino Uno and Raspberry Pi cost, which is rupees 425. And for the Raspberry Pi, it's rupees 3,000. And for the Wi-Fi ESP module, this is rupees 165 per piece. So let's say if we install the 10 nodes, so the cost for a single node comes out to be around rupees 6,000. And for the 10 nodes, it will be 60,000 rupees. And if we include the server cost over here, so it comes out to rupees 1 lakh. Market potential. This particular project has a huge market potential. Consumer and product type. Smart hardware-based system for water conservation. The market size, since this will be required for every house, so it has a tremendous and huge market size. Help from the various stakeholders. Now to develop this particular project and to scale it, we require the help from the various stakeholders. Like we require the involvement of the consumers at the initial stage to understand the water requirements. Then we require the help from the different R&D establishments working to solve the problem of water conservation, which starts from the common man. Then we require help from the academia and researchers across the water domain. Now I'm dealing with a case study 2, which is the Chennai water problem, and we are calculating the zone-wise deficiency. For this particular problem, the data set has been taken from the Ministry of Housing and Urban Affairs, Government of India, which provides us with the water consumption data of Chennai in a zone-wise manner. Now the deficiency, what is the deficiency? The deficiency is calculated as the demand minus supply liters per day. The implementation has been done in Python. We are able to conclude the project, but before conclusion, I will like to share with you the screen for the zone-wise deficiency calculations. So if you see over here, for the city of Chennai, the various zones are given over there, like Manali, Tondir, Path, and so on. So from the data which is collected from the ministry, we have been able to gather water supply in liters per day and water consumption in liters per day, and we have been able to calculate the deficiency. If you record over here and see the observations, some of the readings are shown as negative and some of the deficiencies are positive. So how we can conclude this particular work? It's like all the zones except 4 of them, the deficiency is positive. What it means basically, this means that the supply is much less than the demand of water in liters per day, and the numbers are alarmingly high. So how we can do it? So how we are able to conclude these 2 case studies? So there is a lot of conclusion, there is a lot of potential with respect to these 2 projects. And the case 1 is, like, the same system can be installed as a network of IOT nodes for housing society which is having multiple water tanks. The proposed IoT-based systems and the analytics engine could help further in understanding the daily, weekly, monthly, seasonal requirements of water for a district or a city and finally the country as a whole. Now, with respect to the case studies 2, the deficiency can be calculated for the various zones, and the deficiency can either be positive or negative, and accordingly provisions can be made to supply water from the negative deficiency areas to positive deficiency areas. So both of the projects have a huge market potential and have huge benefits. So the outcomes of the research work, I would like to take up the first case study. We have been able to publish one paper with the IWA Water Supply Journal, and the author blog post has been published with IWA, and the link has been shared. The patent has been published with the Indian Patent Office, and the patent number is 2019 110 29664. The title of our project is Finding Optimal Water Consumption and Leakage Rate in a Residential Area Using a Smart System. The case study 2. For this particular case study, the work is still in progress, and this is to be submitted for publication. These are some of the references which have been taken. These are essential contacts. Professor Amlan Chakrabarti, professor from University of Calcutta, India. His email ID has been shared with you. Dr. Jyoti Gautam, myself, associate professor at JSS18 Noida, Uttar Pradesh, India. Jyoti, JSS18@gmail.com. Ms. Nitima Malsa, assistant professor, JSS18 Noida, Uttar Pradesh, India. Nitima.malsa@gmail.com. Thank you so much for listening to my presentation patiently. Now I would like to stop my screen share. Thank you so much.
Thank you, ma'am, for sharing knowledge. Thank you all for listening patiently. Dr. Jyoti will share a short video on water loss and impact of COVID-19 on water loss. Ma'am, please share.
The video is related to water loss and increased water prices after COVID-19 in India. The video is a collection of various photographs available online. It is created for the purpose of spreading awareness of water loss in India and the world. The first half of the video starts with water loss happening in different ways indicate the situation of crisis for water availability due to increased ignorance amongst people in the society. Then, the second half of the video signifies the effects on water loss because of COVID-19 in India. And the data has been taken from the Center of Science and Environment, Government of India. The first slide indicates the World Health Organization guidelines, which states a proper hand washing involves lathering soap and scrubbing hands on both sides for at least 20 seconds. Then the data from the Center of Science and Environment says a 30 to 40 second hand wash will use around 4 liters of water if the tap is on, or 2 liters of water when the tap closed, while scrubbing with soap. Around 20 to 40 liters of water is used up every day, with the assumption that every person cleans her hands at least 10 times a day, instead of the usual average of 5 times a day. A family of 5 members would thus need 100 to 200 liters of water per day only to wash hands. So this would result in the generation of around 200 liters of wastewater per day, a 20 to 25% increase in water demand and generation of wastewater from human settlements. The table indicates the need of family of 5 of around 100 to 200 liters of wastewater per day only to wash hands. And the same calculation has been done on a monthly basis. The calculation of waste should be on reducing this water loss and at the same time maintain good hygiene practices to save the population during this pandemic. The need to spread awareness to be water efficient by closing taps or by using taps with sensors that automatically switch off when one's hands are not under the tap during the process of scrubbing soap. Thank you so much.
Thank you, ma'am, for sharing a video. Now I request you all kindly fill Google feedback form. The feedback form link is shared in your chat box. Please, all of you, please fill the form. It will take hardly 2-3 minutes and it is very valuable for us.
Okay, thank you, Nitima.
Thank you.
If anybody has any questions for Professor Amlan or Jyoti, then you can type them into the chat box now. We do have one question from Mordecai, who was asking if it's possible to share the presentation.
Yes, definitely.
Yeah, we can do that.
Okay, so
they can write to us.
They can
write
email
us
to you, yeah?
Yeah, they can email to us.
can you put your email address in the chat box so that people can, they
Sure.
know who to send it to, request to?
Okay, sir. I'm sharing.
There is any question? No, no. Okay. Yeah, Victor, we will do it. Please mail it to us. Yep.
Yeah. Okay, if anybody is interested in the presentations, you can see the 2 email addresses that have been put in by Nitima, acakcs@caluniv.ac.in and Jyoti, jsaten@gmail.com. So if you want copies of the presentation, you can email to either Professor Amlan or Jyoti to ask for the presentation. Okay, no questions? Right, well, okay. Obviously you have the email addresses as well. So if you have any questions afterwards, you can, I'm sure you can email Professor Amlan or Jyoti directly as well with those questions. Okay, well, thank you everyone for your presentation today. I know we had a few difficulties, but I think the message got across somehow.
Thanks, Gary. Thanks.
Yeah, thank you.